All right, so today I'm going to talk about the picture element. Hello everyone, my name's Mike and I'm a senior front-end developer at CrownBet in the city. And yeah, we're going to talk about some responsive images and all kinds of fun stuff. So let's just talk about what we're going to cover. There's three things. We're going to talk about a little bit about why we need responsive images and a little bit about the history of images, why this is an important thing for us. We're going to talk about how we can use image source set and the picture element itself to implement responsive images, and how we can use those new tools for us today. All right, what's the challenge that we face? Well, we're all kind of getting, we're pretty used to responsive design right now, but images have always been kind of one of those sticking points. We've got sort of an image, what might we do? We might sort of maybe pop an image in, we might sort of go, well, our screen might go this big, so I'll just have an image that's that big, and smaller browsers will just download the large one, scale it down. But we've got a couple of challenges that we have facing us there. And the one that really sort of comes to mind is that speed matters. Now, according to Kissmetrics, who probably want to sell you their product, a 1 second delay in page response could potentially result in a 7% reduction in conversions, and that could multiply out to a lot of lost revenue if your company was doing like a large e-commerce site. So the speed of our page, very important. Now we talk about, we spend a lot of time thinking about how we can compress our CSS, our scripts. We've got that pretty good these days, and new stuff's coming out. But those images, they're tricky. So how much of a page is actually taken up by these images? Now this is sort of an aggregate 100 top websites from this HTTP archive site. So this was just generated a couple of days ago. The actual kilobyte's not so important, but we can see there that the images are a huge part of every site that we're making. Like they're pretty big, almost 2/3 there. And if you've gone, as we all probably would have in the Chrome Inspector and seeing the timeline, the waterfall when things render in, the longer it takes for images to download those assets, that can sometimes delay the loading of other assets as well. And that can have an appreciable impact on the speed at which our pages load. So if we're going to approach responsive images, we've got to think a little bit about what we know and what our browsers know, because we're not actually going to solve this on our own, and nor are our browsers going to be able to solve this without us as the authors. So there are four main things, 2 things that we know and 2 things that our browsers know. The first thing is, well, we know how we're going to be displaying these images on the page. We know it's going to be 1/3 of the page, or it's going to have a sidebar on the side, or something's going to, how big is this image actually going to be when it's displayed? And how is it going to change across breakpoints? We also know how big those source images are. We know the widths, the heights. We know the actual file size. The browser could never know this unless it actually downloaded every single image that we gave it and said, oh, that image, that's so many pixels wide. So we know that ahead of time. But the browser knows a couple of these things that we don't. The first one is the browser knows, well, how big is its window? We can't guarantee that as content developers or content authors. But the browser knows, oh, okay, this person viewing it over here is viewing it on their desktop. This person's viewing it on a tablet, it's on a mobile. So the browser knows how big its window is. And finally, the browser knows what its screen density is. So retina displays, high-res displays, those sorts of things. We can't know that ahead of time. But if we put these 4 things together, we can come up with some pretty cool stuff. So enter image source set and the picture element. Now, I'm going to tell a sort of a little story next. I suppose it's probably, well, it most likely has been embellished. So we'll just go ahead and start off with that. Around about the time when the iPhone 4 first came out, which is when it first went high-res, the WebKit team wanted to sort of implement a way to get good high-res images onto the phones, really show off the new high-res display. And so WebKit invented this lovely little thing called source set, and it attached itself as an attribute onto the image tag. And it handled something very simple. It just said, this is a low-res, normal garden variety image. And then we had the high-res image, so the 2 times or at 2x image. And then WebKit kind of said, well, my job's done here. I'm out of here. And they went flying off for a little while. So let's have a look at srcset-x. Srcset-x is great if you have a fixed width image and you need to swap out its resolution. And that's about it. But it is the simplest thing that we can start off with. So let's have a look at it. Here's an image, 640 pixels wide, 1 time, so just standard resolution. Here's our image tag down below. We've got a fallback, which is the normal source. And then this new attribute that you may or may not have seen if you've done a little bit of picture. If you haven't, this is possibly new. This is source set. And the source set allows us to supply a comma-separated list of sources. And in this case, we've said, well, OK, we've got a 640 pixel image. That's when you're going to display this at 1 time, so at standard resolution. But if you have a high-res display, there's a 2 times image, and that image is twice as big. So by default, our standard screen one, maybe not this screen because it's a high-res screen, but if you're on a standard res monitor, the one we're used to for a long time, it will display that 640 pixel image. Even if we double its rendered width, and we said now this image is going to be displayed at twice as big, 1280 pixels, the browser's going to go, no, mate, I've only got this 1 times image here. I'm going to use that. So it'll scale it up. But if we happen to be on a high-res device or high-res screen, and we've got these 2 times images available to us, it's going to say, great, that 2 times image, I'm going to use that, and it's going to look great. So whilst Safari was having a good time with its X source set, a group of very clever people who've been sort of thinking about this for a long time and were inspired perhaps by the release of the srcset-x got together as a group and they said, well, we're going to call ourselves the Responsive Images Community Group. And we're going to work as developers and we're going to sort of come up with a way to sort of say, hey, we've got these other great ideas. What about art direction, cropping images at different sizes and shapes so that you might have a very large image, but you want to crop it down as the size decreases. How can we handle that? What about being a little more permissive with allowing our images to, be chosen intelligently based on the widths of the images, how they're being displayed, what source images we have available to us, rather than this sort of segregated, you have a low-res screen and you have a very fancy high-res screen. Meanwhile, Safari's just busy having a nice little time flying around. It's super happy with itself. One of the results of this is srcset-w. So it's like srcset-x, it attaches onto the image tag, but it allows us to pick a source image based on these available variables. Let's have a look at that now. So here's our lovely 640 pixel thing. And we can see we've actually expanded our source set a little bit. And instead of an X this time, we have a W, and we have some other numbers. Now those numbers there, 1280, 960, 640, 480 in this example, they are the actual pixel widths of those source images. So were you to open up, say, 960 image in Photoshop and check out its width, it should be 960 pixels. If it was something else, you should put that correct width in there instead. So we're giving the browser the information it needs to know about the width of the image ahead of time, ahead of downloading it. Because the whole point of this is we want to be able to have the browser intelligently go and grab just the right image for just the way we're displaying it on just the right device without having to unnecessarily download heaps of other images first and then deal with it that way. But with W syntax, we actually get this extra attribute, which is now required. An earlier version of the spec had sizes as optional, but sizes is now required. And sizes tells the browser, hey, this is how wide we are going to be displaying this image. So in this case, we've said this image is going to be a fixed 640 pixels wide. So the browser goes, all right, you're going to go and fix that at 640 pixels. I see you got a nice little 640 wide image there. I'm going to grab that one because I'm on a single density screen. For interest's sake, if we were displaying this 1 pixel wider, 641 pixels, browsers will favor grabbing the next largest size up, even if that's a significantly larger margin higher. Like if we had a 640 pixel wide image and a 10 billion pixel wide image, it's going to grab the 10 billion pixel one for 641 pixels. It doesn't really do any kind of like halfway between or a third between or any kind of that sort of thing. It will just grab the next highest one. So if we had a double res screen, so 640 pixels with a high res screen, it's going to go, oh yep, 640 pixels wide, but I'm double res, so I'm going to do a little bit of maths, pretty simple multiplication, and pick the right picture to download. But that still doesn't take us much further than the original X syntax. We've still got this fixed width picture. So how do we actually tell the browser, oh, actually, I'm not displaying this fixed. It might be scalable. It might be a proper responsive image. It could be some variable size. Well, Sizes has another trick up its sleeve, and it looks a little like this. And you might be looking at that going, CSS in my HTML? And then you flip the table and you walk away. But no, there is a very good reason for this. And the very good reason is this. We want our images to load as fast as possible. Now the browser downloads the HTML page and starts parsing over the document. Meanwhile, it's going off and retrieving the CSS, but we don't want to have to wait for it to finish retrieving the CSS before we start grabbing those images. So we can't rely on CSS being present. That's a very important thing, because that also, there's a couple of extra little bits and pieces in here which are a result of this limitation. So we can't rely on our CSS file. That means the M width there, 50 Ms, is untransformed. So even if we did some fancy, lovely typography stuff, which you might do, say, to set your rem size on the HTML tag, which would change, therefore, the rem value, or even the M value, that does not get taken into account with the picture tag. The picture tag always assumes a clean 16-pixel default slate, regardless of what you might do in your CSS file. The other little thing you've got here is, you may have noticed, 33.333. I tend to like 5 decimal places, just a thing. But we've got viewport units, viewport width units to be precise. Well, why viewport width? Why not percentage? Oh, something like that. Here's the other thing. As you may well know, when you set a width of a percentage, it could be relative to its parent. It could be relative to some other element on the page. But our CSS has not loaded yet, in theory. So we can't rely on a percentage because it's ambiguous. So we have to set these responsive values in either a fixed value, such as pixels, or we can use viewport width units. For those of you who haven't used viewport width units before, 1 VW is 1/100th of the width of the screen, and 1 VH is 1/100th of the height of the screen. So it's basically 1%, but explicit to the actual full width of the screen. Slight interesting caveat, just side note, not actually just something I thought of then. When doing a site at my last job, we discovered that 100 VW includes the width of any scroll bars if they're there, like on Windows or if you've got it set on a Mac. But 100% width will not. It'll sit inside. So that's just a little gotcha you might need to keep in mind, that 100 VW includes the width of any scroll bars visible. All right. So percentage values are not allowed, and M units can be a little bit of a gotcha there because they're untransformed. Now, a couple of other browsers came along and said, indeed, responsive image community group, this is a good idea. And they got on board with it. So we started to see the seeds of development. Now, this sort of happened a couple of years ago now. It's sort of around about 2013, I think, was sort of the main initial beginning of all of this. And this is probably around about late 2014 that the browsers started to come on board. Because originally they were like a spec that we didn't write. And so there was a couple of people who were very talented who'd worked both on browsers and with the RICG group who had actually experience in writing actual specs that the browser makers like. And they were able to bridge the gap. And that's when things really took off and the browser makers really got on board with this. Meanwhile, there's this little browser that comes along and says, ooh, like what these guys are doing over here. That's kind of interesting. I'm going to go implement the X syntax source set. So that's what they did. But let's come across to the picture element proper. So we've looked at srcset-x and we've looked at srcset-w. Now we take those a little step further. Srcset-w, one thing I didn't mention, but I'll mention it now, is it has what I call permissive image caching. That is, it will, once it's grabbed a large image, even if you scale it back down and it's got another smaller image cached, it will hang on to that large image and it will use that large image. So if you've got a 10,000 pixel wide image that it's cached, because you've got a magically impossibly large screen, and you scale it all the way down to 320 pixels, it's still going to have held on to, very tenaciously to that 10,000 pixel wide image, and it's going to be scaling it down in memory. Now that may be an acceptable thing for you, that may be a challenging thing for you, but that's another thing with srcset-w. It has permissive caching. But the picture element is going to show us how we can actually get around that. First, we'll look at X syntax version. So here's our friend, the picture element. And we can see at the bottom there, we've got a little image tag and some new tags, the source tags. What are they there for? And yes, they've got media queries in them. So and similar to W syntax, as the sizes, the M units in there, for example, are untransformed. They do not assume that CSS has existed at that point. Well, unlike video and audio, where you may have seen the source tag used before, even though we're using picture, the picture element itself is actually a non-rendering thing. It just acts like a container. And that little image tag down there is the actual image that is displayed on the page. So our image tags that we've been using today, and when we go and start to use the picture element with image tags, the image tags are still what we style. They're still what we give the widths to. The sources all exist to feed a source into the image tag itself. And they evaluate from top to bottom, I believe. And so once one of those matches, it'll have a look at what it's got available in its source set, and it will feed that source into the image tag. Now, in a native browser implementation, so no polyfills or anything like that, this will actually override loading the source there at the bottom there, which would be image 320 in this case. So it will actually load just the right image and only the right image based on the sources that we've provided. So that's pretty cool. Now, I've just provided the one-time images there. With X syntax, you can actually leave that off if you want. If we just dropped off those 1x's, it would default to assuming 1x. So we can do that, but we could also supply 2x's. Of course, that will work as well. Now, thankfully, all the browser makers came to a bit of an agreement, and they've all now started to join in, have a bit of a party. And yep, even Safari and Edge are now there with full picture support, full srcset-w support, and we can all have a bit of a celebration. So let's talk about the final main picture use here. This is picture W. You can mix different sources, by the way, but you can't mix X and W within the same source set. All right, so it's a little bit more complicated, just a little. So again, we have our source set with the various widths and just the widths that might apply to that particular source. So first, it will match the source media and say, hey, is that the one I'm going to use? Yep, cool. I'm going to go and figure out which of these images are my source set based on the width and the sizes and how it's going to be used, and I'll grab the right one. Cool. So pretty much the same sort of building up from what we did before. Now, of course, you could also have further media queries within the sizes attributes. So we've got the media attribute on the source, and we can also have further sub-media queries inside the sizes, just to go and make things extra interesting. So let's now skip the simple examples and jump straight into a trickier one, because, hey, why not? So this is based on sort of an abstracted version of a site that I worked on earlier this year, which is the Melbourne Fashion Festival. We had a thing, you'll see in a sec, I'll show you right now. We have this thing where at small size, we've got a hero image and then some images down below. And at this small size, all these images are rectangular in shape. Okay? As we get up a little bit, the hero image expands out a little more. One of those images, or a couple of them they might expand to fill 2 columns now. We've got 2 columns available to us, and some of them now become squares. So we've got art direction in there. We've changed from a rectangle into a square. We don't want to have a square at this size that's supposed to be a rectangle, and a rectangle that's a square. So we've got some art direction happening. At larger size, it goes to 4 across. We get a little bit larger, and we introduce a fixed width sidebar. Now at this point, I'm just going to pose a mental question to you. Given that the sidebar is, say, 17.5 EM, untranslated, the gutters there, the gaps between the columns, are 3 VW. How wide are those images in VW? How would you calculate that? We will do that, but just having a bit of a think about it. And the last one, of course, is the fixed width sidebar, hero across the top, and the images in a 4-width column there. That fixed width sidebar, that's a tricky beast. So there are 3 images we're going to look at: the hero, the rectangular one, and the square one, which is a rectangle at the smallest size. So let's have a look at what we can do for the hero, and we're going to allow a bit of permissification here. So the hero is pretty simple. It's just an image, has some sources available to it, and above a certain size, we can use the CSS calc to subtract the width of the sidebar from 100. And that's whatever remains must be the width of our hero. Browser figures it out, all good. At smaller sizes, it's full width. The next one, the rectangle, a little bit trickier. This is where we get those gutter calculations coming into play. So we've got 100 minus, at the large size, there's 4 columns across, so 5 gutters. So 5 gutters times 3 VW, the gutter width, minus the width of the sidebar. And because it can be placed 2 across, so 2 rectangles side by side, we have to divide that by 2. The ones that are in the middle that are full width, we do the same thing, but we just don't divide it by 2, and so on and so forth. Now that last one, that square that becomes the rectangle. Are you ready for this one? Here it comes. So we have to introduce the picture element at this point because we need to use those sources to force feed that image tag there and explicit at the larger size, a square, and at smaller sizes, a rectangle. Now I have added some extra stuff onto the image tag itself just as a kind of a fallback. There was a sort of a stage where some browsers were being a little bit funny. Ordinarily, we could just sort of have the image tag on its own and rely on the sources, but that's sort of there as a bit of a help. But for the squares, sort of same deal, 100 minus the gutters, minus the sidebar, but divided by either 4 for 4 across, or 2 for when it's 2 across. Bonus feature for the picture element, we can actually swap out images based on their MIME type as well. This is a very simple example. So we've got a picture, and we can just give an idea of what MIME type that might be. Here we've got a SVG, a PNG, and a fallback GIF. Now, browsers that support the picture element are probably going to support all 3, so this is a bit redundant. But maybe for future image formats, WebP comes to mind, JPEG 2000, something that's not supported across the board. This is a really good way to do that. But I kind of like it. I'm kind of not sure about it. Because if we do that, for every source that we have in a picture, we'd have to multiply that by the number of different types of images we wanted to choose. So different types, and so on and so forth. We could double or even triple the number of things we have to write into our picture. Let's summarize. srcset-x, good for size changes. srcset-y, good for letting the browser permissively pick an image, and it'll hold onto the larger ones and scale them down if need be, even if the smaller one's cached. We can use media queries. Remember, we can't use percentage as a unit, but we can use fixed units or VW units and a couple of others. And picture itself is great for forcing, choosing a particular source, for art direction, and for picking an image MIME type. A couple of little limitations. Calculating VWs can be tricky, as we've just seen. Should we write these? Well, you might write the sort of the structure of an image once, but ideally you'd probably want to be able to template that somehow and use a CMS or something else to input the right values in there into your template. So you probably wouldn't want to write this for every single image by hand and be bespoke. That would be a bit crazy. It also won't solve the problem of if you have a space and you need to fill the image to fix it. That's really still the domain of background size and CSS backgrounds. Smaller side, I did write a little script that does that there. You can check it out if you like. So how can we use this today? Well, with srcset and picture, all the major browsers now have native support. So that's latest versions, which is great, on mobile as well. But for all other cases, and for supporting older browsers, there is probably the canonical script here, the canonical polyfill, picture fill. If you want to use picture, it's pretty much a necessity at this point until browser support is and the audience for it is big enough. But it's great. The people of Scott Gell and the other contributors have done a fantastic job on it. They've rewritten it a couple of times. It's really good, pretty bulletproof. It does have a slight thing in that it sometimes has a few things where, because it's a JavaScript, you might need to work around trying to download images twice or something like that. Small price to pay. And a lot of CMSs, such as WordPress, Drupal 8, etc., are implementing picture natively into their systems. And there are also plugins available. We're almost there. One last little thing. I did spot this, The Verge is using picture element in the wild. So that little picture there, well, not little actually, it's the hero picture. But that picture there it's a picture element. Let's have a look at its source just quickly. So there's the picture, and it actually looks a little bit like this. That's one image, by the way. I don't know about you, but I've actually written web pages that probably were smaller in size. But that's a little bit unfair. There's a lot of very long URLs in there for their CDN. So let's actually pull that apart and just have a quick look at how it's actually happening here. So really, this is just srcset-y syntax. Permissive size. They've got the sizes there set up of how it's going to be displayed, how it changes. And they've got a lot of different possible sources it can pick. So they really wanted to optimize like the granularity of those images. And honestly, if they didn't want to support WebP there, they could have just had that one image tag. So they've actually doubled their code size, as we saw there, just by supporting WebP. But maybe there's some really good performance benefits, file size benefits there in supporting WebP. Lastly, how to get a bit of information. Actually, although specs can be a bit dull to read through, I do recommend reading through the official specs. Just have a quick browse at it. It can illuminate a few interesting points. Of course, check out the RICG. You know, they've done some great work. They're moving on to a couple of other projects at the moment, but they've been the champions of us developers throughout this whole process. Oops. Can I use is always good, just for checking out the support of what your browsers you may or may not need to support. So srcset and picture, there's slightly different support, mainly because srcset-x has been available for longer. And lastly, I did make a little project where I sort of have documented this, and all the examples that I've used today have sort of come from this little project there. I need to do browser testing, but if you check it out and you've got any feedback, I'm always welcoming of feedback, changes, and maybe some extra examples if you happen to be interested in doing that. So thank you.